Alemania esperaba encontrar un tanque común, pero descubrió un secreto que cambiaría su forma de entender la guerra para siempre.
Instead, it was a single American tank sitting silently on a proving ground south of Berlin. To most officers, it looked ordinary, an M4 Sherman coated in desert dust, its armor carefully measured and marked with chalk. But when German engineers climbed inside and examined every bolt, every control, and every mechanical detail, they uncovered something far more unsettling than thicker armor or a bigger gun. They found a machine built around an idea that Germany could no longer match. It was a discovery that quietly challenged everything the German Armored Corps believed about winning modern war. On the morning of April 14, 1943, engineers at the Kummersdorf Proving Ground gathered around the captured Sherman with professional curiosity. Every surface was inspected with scientific precision. Armor angles were recorded, steel samples measured, and mechanical systems dismantled piece by piece. Nothing escaped their attention. Yet as the inspection continued, the questions changed. They were no longer asking how powerful the tank was. They were asking why it had survived conditions that crippled many German vehicles. The Sherman carried the scars of the Tunisian campaign, where Allied and Axis forces had fought across endless stretches of desert under brutal conditions. Dust had settled into every corner of the vehicle, yet the engine still started smoothly. The transmission shifted without complaint. The suspension remained intact despite hundreds of kilometers of rough terrain. For engineers accustomed to highly sophisticated, but increasingly fragile, German machines, this reliability was impossible to ignore. To understand why this single tank caused such concern, we must return 2 months earlier to the deserts of Tunisia. In February 1943, the United States Army faced one of its greatest early tests in the European theater. Many American soldiers had trained hard, but few had experienced the chaos of modern armored warfare. When German panzer divisions launched their offensive through the mountain passes near Kasserine, American units suddenly found themselves fighting one of the most experienced armies in the world. The result was a painful lesson. Communications broke down, formations became scattered, and many young crews found themselves facing veteran German tank commanders for the very first time. The battle became one of the most difficult moments for the WWII army during the campaign. Numerous Shermans were destroyed, while others were abandoned as inexperienced crews withdrew under intense pressure. Among those abandoned vehicles was one particular Sherman later identified by German troops and transported back to Germany for detailed examination. Unlike many captured tanks that were stripped for spare parts or quickly tested on firing ranges, this one received extraordinary attention. Hermann High Command ordered that it remain untouched until engineers completed a full technical investigation. The decision revealed something important. Hermann commanders were not simply interested in another enemy vehicle. They believed this tank might reveal how American industry was rapidly expanding its military power across multiple continents. When the Sherman finally arrived at Kummersdorf after its long journey from North Africa, engineers expected to confirm what many already believed, that German engineering remained unquestionably superior. Instead, every hour spent studying the vehicle forced them to reconsider that assumption. They found no revolutionary weapon hidden beneath the armor. No secret technology explained its success. The Sherman was, in many ways, remarkably ordinary. And that was precisely what made it extraordinary. What German engineers were about to uncover was not a better tank, but a better system. It was a philosophy of design, production, and battlefield maintenance that would eventually reshape the balance of the war. By the time they fully understood its significance, events on the battlefield were already proving that this quiet American approach could be every bit as decisive as the most powerful gun ever mounted on a tank. The inspection at Kummersdorf was unlike anything the captured Sherman had experienced before. This was not a battlefield examination carried out in haste. Germany's premier proving ground had spent decades evaluating military technology with remarkable precision, and every engineer assigned to the project understood that even the smallest mechanical detail could reveal valuable intelligence. The Sherman was rolled into the workshop, cleaned, documented, and assigned a formal test number. Measurements covered every surface of the hull and turret. Armor thickness, welding methods, casting quality, suspension geometry, and engine components were carefully recorded. Nothing was considered too small to study. At first, the engineers believed they were confirming what they already knew. The Sherman's armor was respectable but hardly exceptional. Each 75mm gun was effective, yet it did not outclass Germany's newest weapons. Compared with the Panther or Tiger, the American tank seemed technically ordinary. But as the examination continued, the engineers began noticing something unexpected. The vehicle had survived a long journey across North Africa before reaching German hands. Hundreds of kilometers of rough roads, dust, air, and constant vibration had failed to produce the kinds of mechanical failures German maintenance crews often expected after such punishment. The engine still ran smoothly. The transmission shifted cleanly. Even the suspension components showed surprisingly little wear. That level of reliability demanded a closer look. The engineers removed road wheels, transmission parts, engine mounts, and numerous internal components, expecting to find carefully hand-fitted machinery similar to German practice. Instead, they discovered something entirely different. The individual parts appeared simpler than their German equivalents. Machining marks were visible. Castings lacked the polished finish found on many German vehicles. To engineers trained in traditional precision manufacturing, the workmanship initially seemed almost crude. Then they performed a simple experiment. Components taken from one captured Sherman were fitted onto another Sherman built months earlier at a completely different American factory. Without filing. Without reshaping. Without the careful hand adjustments German mechanics considered routine. Every component fit perfectly. The significance was impossible to ignore. American factories separated by hundreds of kilometers were producing identical parts that could be exchanged immediately in the field. A damaged transmission could be removed from one tank and installed in another without requiring specialist machining. A broken suspension assembly could be replaced within hours using standard equipment carried by ordinary maintenance crews. Sherman armored production worked very differently. Many German vehicles relied on components that often required individual fitting during assembly. Even parts manufactured for the same model could demand careful adjustments before installation. Skilled craftsmen produced remarkable machines, but every additional hour spent fitting components slowed production and complicated repairs. The Sherman represented the opposite philosophy. It had not been designed to impress engineers. It had been designed to remain in service. As the investigation continued, another feature caught the engineers' attention. Mounted inside the hull was an auxiliary power unit capable of supplying electricity without running the main engine. Radios, lighting, and several onboard systems could operate while conserving fuel and reducing engine wear. It was a practical solution to a practical problem. For tank crews waiting in defensive positions or operating during harsh winters, this meant greater comfort, lower fuel consumption, and less mechanical stress. Sherman vehicles generally depended on keeping their main engines running whenever electrical power was required, consuming valuable fuel while increasing wear on already overworked machinery. The Sherman's interior revealed the same philosophy everywhere the engineers looked. Controls were arranged logically. Crew positions allowed easier movement inside the fighting compartment. Maintenance panels could be reached without dismantling half the vehicle. Accessibility had clearly been considered from the earliest design stages. None of these features were individually revolutionary. Together, however, they revealed something far more significant. The Sherman had not been built to win engineering competitions or showcase technological brilliance. It had been designed so that thousands of ordinary mechanics could repair it quickly, thousands of factories could build it consistently, and thousands of crews could keep it fighting under almost any conditions. For the engineers at Kummersdorf, this realization marked a turning point. They were no longer evaluating a single American tank. They were confronting an industrial philosophy that challenged Germany's entire approach to armored warfare, a philosophy that valued reliability, simplicity, and standardization over perfection. Before long, that difference would become impossible to ignore, not inside a laboratory, but across the battlefields of Europe. By the summer of 1944, the conclusions reached at Kummersdorf were no longer confined to engineering reports. They were unfolding across the battlefields of Western Europe, where Allied armored forces were advancing in numbers that Germany struggled to comprehend. Every destroyed Sherman seemed to be replaced almost immediately. To German commanders, it often felt as though the American supply of tanks was endless. The truth was more impressive than any myth. Behind every Sherman stood a production system unlike anything the world had seen before. Across the United States, factories that had once built automobiles, locomotives, railway cars, and heavy machinery had been transformed into tank assembly plants. Companies with little or no previous experience in armored vehicle production were suddenly building thousands of identical machines using standardized methods and interchangeable parts. These industrial networks stretched across the country. Although each factory operated independently, every Sherman was built according to the same specifications. A road wheel manufactured in Michigan could be installed on a tank assembled in Ohio. An engine produced in one state could replace another hundreds of miles away without modification. The tank was no longer a handcrafted machine, it had become part of a carefully organized production system. That difference became decisive after the Allied landings in Normandy. As thousands of soldiers came ashore on June 6, 1944, they were supported not only by tanks but by an enormous logistical network prepared months in advance. Landing ships carried engines, transmissions, tracks, road wheels, radios, and thousands of spare components alongside fuel and ammunition. Mobile repair workshops landed soon after the assault forces, giving mechanics the ability to restore damaged vehicles close to the front. The goal was simple: keep tanks moving. American maintenance crews followed a structured repair system. Minor problems were handled by the crew themselves. More complex repairs were completed by company and battalion workshops, while heavily damaged vehicles were evacuated to larger repair facilities farther behind the lines. Because every major component was standardized, mechanics could replace entire assemblies in hours rather than days. A Sherman disabled during combat often returned to service remarkably quickly. Sherman maintenance crews faced a very different reality. The Panther was one of the most formidable tanks of the war when fully operational. Its powerful gun and well-sloped armor gave it impressive battlefield performance. Yet those advantages depended on a machine that demanded constant maintenance. Final drives, transmissions, and other critical components frequently required specialized repairs, while replacement parts became increasingly difficult to obtain as Allied bombing campaigns disrupted Germany's industry and transportation network. As the fighting intensified across France, these mechanical problems became impossible to ignore. Sherman crews often found themselves waiting for parts that never arrived. Tanks remained parked behind the front lines while experienced mechanics worked tirelessly with limited tools and shrinking supplies. Every disabled vehicle reduced combat strength, regardless of how powerful it appeared on paper. Meanwhile, American armored formations continued pushing forward. Even after fierce engagements in Normandy's dense hedgerows, many damaged Shermans were repaired, rearmed, and returned to action within days. Crews understood that losing a tank did not necessarily mean losing the battle. A replacement, or a repaired vehicle, was usually on its way. This consistency produced an important psychological advantage. American crews developed confidence that their equipment would continue operating under demanding conditions. Sherman tankers, by contrast, increasingly worried that mechanical failures might end a mission before enemy fire ever could. Reliability became more than an engineering achievement, it became a factor that shaped morale. By late 1944, the contrast between the two systems was becoming unmistakable. Germany continued producing technically impressive armored vehicles, but every new tank required precious materials, skilled labor, and increasingly scarce resources. The United States focused on something different, building machines that could be manufactured quickly, repaired easily, and returned to combat with minimal delay. The engineers at Kummersdorf had recognized this philosophy more than a year earlier. Now the battlefields of Normandy were proving them right. The contest was no longer simply between individual tanks. It had become a contest between two industrial systems, and one of them was beginning to overwhelm the other through reliability, organization, and the extraordinary ability to keep its armored forces in the fight. By the beginning of 1945, Germany's armored forces were fighting a battle they could no longer win through technology alone. Their tanks still possessed impressive firepower, experienced crews, and some of the finest engineering of the era. Yet every passing month exposed the same weakness that German engineers had quietly identified back at Kummersdorf. Winning a battle required more than building an exceptional tank, it required keeping the tank in the fight. As Allied armies advanced deeper into Western Europe, German maintenance units struggled to recover damaged vehicles, secure replacement parts, and restore combat strength. Fuel shortages, damaged rail networks, and relentless Allied air attacks slowed every repair effort. Even when factories produced new Panthers and Tigers, getting them to the front became increasingly difficult. The United States faced many of the same battlefield challenges, but its industrial system answered those challenges differently. M4 Sherman was designed with standardization in mind. Spare parts moved through an organized supply chain. Mechanics followed established repair procedures, and replacement vehicles arrived in numbers that Germany simply could not match. The result became clear during the final months of the war. Again and again, American armored divisions entered battle with high operational readiness because damaged tanks could be repaired, rebuilt, or replaced with remarkable speed. German formations, meanwhile, often watched their strength decline, not only because of combat losses, but because mechanical failures and supply shortages left valuable vehicles sitting idle behind the front. Some German crews eventually found themselves operating captured Shermans during desperate defensive actions. Many expected these American tanks to feel inferior to the powerful machines they had trained on for years. Instead, they discovered something unexpected. The controls were straightforward. The transmission shifted smoothly. The turret responded quickly. The engine started reliably, even in difficult conditions. The vehicle was comfortable enough to reduce crew fatigue during long operations, and routine maintenance could often be completed without specialized equipment. It was not luxury. It was intelligent design. The Sherman had been created for ordinary soldiers operating under extraordinary circumstances. It did not rely on perfect conditions or flawless maintenance. It was built with the understanding that war was unpredictable, repairs would be necessary, and crews needed equipment they could trust every single day. That philosophy ultimately became one of America's greatest strategic advantages. History often remembers the Second World War through dramatic tank duels, famous generals, and decisive battles. Those moments certainly matter. But behind every victory stood thousands of workers, engineers, mechanics, railway crews, factory managers, and supply specialists whose contributions rarely appeared on the front pages of history. The Sherman became a symbol of that collective effort. It proved that reliability could outweigh perfection. That a machine designed for mass production could influence history as profoundly as one built for technical excellence. And perhaps most importantly, it demonstrated that industrial organization, logistics, and maintenance could become weapons just as powerful as armor or artillery. When the war finally ended in Europe, the lessons learned from the Sherman did not disappear. They shaped military thinking for decades, influencing how modern armored vehicles were designed, manufactured, and supported across the world. The engineers at Kummersdorf had set out to evaluate an enemy tank. Instead, they uncovered a lesson about modern warfare itself. In the end, the Americans did not simply build a tank that could fight. They built a system that could endure. And in a conflict where endurance determined victory, that difference changed history. Thank you for watching. If you enjoyed this documentary and learned something new about the hidden story behind the Sherman tank, consider supporting the channel with a like and subscribe. It helps us continue exploring the untold stories of World War II through careful research, historical accuracy, and cinematic storytelling. Let us know in the comments, what overlooked innovation do you believe had the greatest impact on the outcome of the war? Until next time, thank you for watching, and we'll see you in the next documentary.